And today we are going to see about in mechanics D Alembet's principle or Lagrange form of D Alembet's principle. For this, the statement says that the sum of all forces, which means a real and inertial force acting on a particle of a system, is zero. So, consider a system containing some particles. So, the real force and inertial force acting on this particle or system will remain constant, that is called zero. This is the statement of Lagrangian form of D Alembet's principle. For proof, we are considering having n particles of mass mi and the position vector ri at the time t, the equation of the motion, or we are considering this equation, that is fi vector plus ri vector minus mi ri vector double dot equal to 0. So here in the system it contains n number of particles, and also that n number of particles has some mass, so that is mi. After a time t, the particle moves from one position to another position, so that that the difference is called position vector, that is we are mentioning as ri vector. So from the equation, we are considering the equation of the motion of the particle will be the fi plus ri minus mi ri vector double dot equal to 0. So here fi plus ri vector are nothing but real forces, and minus mi ri vector are called inertial force. That both forces acting on one particle means the system remains constant, that is our statement. So we want to prove this. Here fi are nothing but applied force, and ri or the constraint force. Applied force are no. For example, if we want to move the table, we have to apply some force. That force is called the applied force, and ri is the constraint force. If there is a friction in the table, so that is called constraint force. So fi plus ri, or both the forces are called real force, and other name is known as actual force. And here minus mi ri vector double dot is called the reverse effect force or inertial force. So this ri nothing but acceleration to the relative to the inertial frame. So in the system it is having some inertial frame. If after time t the particle move from one place to another, so according to the inertial frame, the acceleration of the particle is called ri vector double dot. So from the equation 20, fi vector plus ri vector minus mi ri vector double dot equal to 0, the reverse effect of the force or inertial force together with the other force keep the system in the equilibrium. So the inertial force together with other force keep the whole system in the equilibrium, that is 0. And we are considering if there are some if the displacement happening means there are some work done will happen. So del ri vector be the virtual displacement consistent with the constraint of the system. So if having some displacement means there must be some work done. So work done equal to force into displacement. We are considering this one is nothing but force, and displacement we are considering dou ri. So dou ri vector for displacement, and force is this one. We are considering n particles, so I equal to 1 to n equal to 0. And the constraint force, here we are assuming that the constraint force is 0. There, for example, there is no frictional force, so the constraint force will be 0. So if we multiply the summation and del or I vector means we get this as 0, and the left of the term is summation I equal to 1 to n fi minus mi ri vector double dot dou ri vector equal to 0. So this is called the Lagrangian form of D Alembet's principle. Hope you all understand, and thank you.